There'll be 7W7, and how many X are left? If you have X nines, but you pull out four of them, right? So 7W7 X, what power?
X to the X to the like X to the fifth.
Exactly right.
I can't open everything up there. Da, 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 da.
Okay. Hold on, slow down. Let's see here. So what you do is you gotta group the first. So it's like that factor and flow chart. When you have four terms, you do this,
Mhm.
and you pull out common factors from each group.
Yeah. So you could do. Oh yeah, this is the. I was doing one of these problems with my teacher at lunch.
Okay.
Um, let me see. Here, can I write this down real quick?
Sure, go ahead. Yeah.
Sir. Okay. Hold on, let me try out the problem. Okay.
Okay.
I'm trying
Yeah.
out the problem real quick.
Yeah. Write that and figure out how much you're gonna figure out what to pull out from the first group and what to pull out from the second group, and then something interesting will happen after that.
So we have to put it when you put it in combined like factors or like like problems, like problems that are like the same. Look,
Yeah. Yeah. So what do you pull out of the first group?
um, 10, 10U
Well, actually, 5U squared.
of oh, I meant pull. I thought you meant like actual numbers. Yeah, 5U squared, and um,
What's left inside?
then it'll be 25U squared. Oh no. Then what's left inside is so it'll be 7E. It'll be
Okay.
seven.
Take
Seven.
it. No, slow down. What's 10 divided by 5?
2.
And we have U3. You took out U squared. What's left behind? We take out U squared from U3. Remember, U squared is two
U
U's.
squared, two
U3.
U squared, 2U squared.
Okay, hold on. Slow down. 10U cubed is this, right?
Yeah.
All right. You took out 5U squared, 5U and U.
Mm-hmm.
How many U's are left now?
2.
Take a look at the screen. It's pretty
That's
obvious.
I was looking at 1.
One U, exactly. And 10 divided
Oh,
by 5 is 2.
to my credit, you did not cover that U until
So
after.
it's 10U,
Yeah.
2U, 2U. Okay, then 25U squared, you have 25U and U, right?
Yeah.
If you take out two U's, those are gone.
So no,
Well, what's 25 divided by 5?
5.
5. Now, here's the reason why this works. Because if I were to put that 5U squared back in, I get 10U cubed
Yeah.
and I get 25U squared. So you have to guarantee that you get back to the same thing after you factor.
Mhm.
which I do now. Okay, so now that the first group is done. Now let's do the second group. The second group is 14u plus 35. What do they have in common?
They're both factors of 7, so it'd just be 7.
Yes, good. And what's left inside? When you
Uh,
divide this by 7, what's left inside?
for you.
2u
Oh, to you.
plus
Uh, well,
plus
5.
5.
Yeah.
Okay, now notice that these are identical.
Yeah. So it's
Pull it
cancel.
out. You pull it out.
Yeah.
When you
So
pull it
just
out, you have 2u plus 5 on the outside, and what's left behind? 5u squared and 7.
yeah. So that would be 5u squared is the answer.
No, the answer is 2u plus 5 times 5u squared plus 7.
Wait, what?
That's the answer, what I just circled.
Oh, really? Oh.
Well, yeah, of course, it's still, of course, there's a 7 at 5u squared. I mean, you just fact, basically what you're doing is you have 5u squared times a group plus 7 times another group.
Yeah. So if
That
I'm
2u plus 5 gets factored out, and what's left behind is a 5u squared plus 7. So you have 2u plus 5 times 5u squared plus 7.
sorry if I'm going low, so that's my second time ever doing
No,
it.
no, it's all right. That's what you gotta do.
Am I supposed to like put plus? Or what did I do wrong? Right.
See?
Uh-oh.
Yeah, 2u plus 5 and 5u squared plus 7. You put plus 4.
Plus 7.
Yeah, exactly. Because there's a 7.
Oh yeah, that looks like that makes sense. Okay.
All right. So I'm gonna let you try this on your own.
Okay.
So you have the first, so figure out what to pull out from the first group, figure out what to pull out from the second group, and then you should get whatever's left behind it should be identical for both groups.
But you would times this then, right?
You're pulling stuff out. So look at the first group. What can you pull out? It's all about pulling out. That's all it is.
20x, right?
No. Okay. You have 20x versus 25xy.
Yeah.
So you got to figure out what's common between both of those. What are you going to pull out?
5.
That's better. Yeah, I like that. 5. And what else?
To
What else do you have in common?
uh honestly, I think
Look
5.
at look at the letters.
Oh, x.
Okay, good. Now, when you take 5x away from 20, when I say take away, what I mean is divide.
Yeah.
When you do 20x divided by 5x, what does that become?
20x divided by 5x.
Yes.
Oh, it's 5x.
What's 20 divided by 5? That's all I'm
Oh,
asking you to do.
4x.
But what happens to the x's?
The
Because you have
x
x over x. What's x over x?
x over x is 2x. Oh, what? No,
X divided by x.
it's x.
No.
What? Oh, it's negative 2x.
Okay, what's 2 divided by 2?
1.
So what's x divided by x?
1.
Yeah. So the answer is 4.
I don't know what I was trying to do with that, but
Okay. Okay, 4. And then take away 5x from 25xy.
Plus 25.
Okay. So just do 25 divided by 5 and take the x away from it.
25 divided by 5 is 5.
Okay. And then you took away an x, so that x is gone, and you still have a y there, right?
Yeah.
There you go. Okay, now you got to do it again for the second group. So figure out what to take away from the second group. So look what they have in common. Let me get rid of all this here. Okay, so you have negative 12 and negative 15y.
Yeah.
What do they have in common?
Negatives. They're both
Good. I like that. I
3.
like that. And what else?
3. They're both.
Good. I like that. Good. So now your goal is to
Oh.
divide each of these by negative 3. Divide that by negative 3 and divide that by negative 3.
Yeah.
So what's negative 12 divided by negative 3?
Negative 12 divided by negative 3 is positive 4.
Good. And the next one?
Positive 5.
Good.
Um, mm, mm. Think I have a widow's peak. That's just a genuine question.
What was that, sorry?
I'm trying to see if I have a widow's peak right now. I learned about biology the other day.
What does that mean?
It's like when you have a vivid like um like a special like shape in your hairline or like the top of your hairline.
Oh,
Where
never
it's
heard
like
of that before.
or like you could see where
Okay, it
kind
was
yeah.
okay. So yeah, when you divide negative 12 by negative 3, what do you get? You get 4
Yeah, 4. And then 5.
plus 5,
Hmm?
not plus 5, plus 5.
Why?
Good. Because these have to be identical.
Yeah.
So now the final answer is 5x minus 3. Oh, geez, sorry, it's my bad handwriting. 5x minus 3
Minus 3.
and 4 plus 5y. That's the answer.
Eric, can I go to the bathroom really quick?
Sure, take your time. You're good.
I know what I got wrong. Oh my god. Yep. Okay.
Yeah, figure out what they have in common.
All right.
So you have a giant parentheses here. So you have 9 and 27. We'll start with that.
3. 3.
Mm-mm.
9.
No.
9.
Yeah, 9. Okay, good. So then you have U6 and U4. So which of those will you take out? You always go with the lower one between
4.
U6 and U4. Okay,
4.
good.
Yep.
And then W7, W4, which one's lower?
4.
W4, good. And there's no Y's in both of them, so you don't worry about that.
Yeah.
Now, if you look at the first group, what did you yank from it? You yanked away a 9, you yanked away U4, and you yanked away W4. So
Yeah.
it's U squared and W3. Does that make sense?
Uh,
Right?
yeah.
Because it's all about yanking stuff out and what did you leave behind? It's kind of like you went to a department store. Like, these are the things I want. I took all these things off the shelves. What's left over, right? So I want 4 U's. Okay, this store had 6 U's. I took 4 and there's 2 U's left. It's kind of like, there's 6 Tom Brady jerseys. I took 4 of them. I left 2 behind.
Yeah.
And then W is like, okay, there's like, 7 Brock Purdy jerseys. I took 4 of them, left 3 behind. Things like that. And now the next one, 27 divided by 9 is 3. You took all the Tom Brady jerseys out. There's none left.
Yeah.
You took all the Brock Purdy jerseys. There's none left. Y5, that's Jimmy Garoppolo. No one wants Jimmy Garoppolo.
He's a bum.
Yes, right. And there you go. Think of it like that, if that helps. Okay, just give you something more tangible. Okay, now, yeah, so let's try the next one. Okay, good. Okay, this is factor by grouping, but still the same concept, right?
Yeah.
So you're going to group the first two.
So that'll be 10.
No. Just see what they have in common. So basically, they don't have any numbers in common, so forget about that. But you have V3 and V2. Think of V like now a Christian McCaffrey jersey.
Yeah.
Three V So the first one's like Target. They have three McCaffrey jerseys. The other one's like, I don't know, some sporting goods store, like Dick's Good Sporting Good. They have two of them. So you're gonna take out V squared.
Mhm.
So then you leave behind a V here, and you took all the V's from the second one.
Yeah.
Okay, plus, okay, 9 and 21, what do they have in common?
Three. Oh no. 9 and 21 is
Yeah, you're right, it is three. You're right, it is three. And it's 3V minus 7 again. So it's V squared
wait.
plus 3
Mhm.
times 3V minus 7. There you go.
Uh-huh.
Okay, let's move on to the next one.
Okay.
All right, so let's see here. Okay, so same thing, back grouping.
Yeah.
So I can't take anything out for the first group, so it's just going to be, actually, hold on, I'm covering it, aren't I? Yeah, there's an S, my bad.
Mhm.
So M minus R, and then take out a 2, actually a negative 2. So it's S minus 2, M minus R. It's a little bit funky one.
Yeah, I didn't really know how to go with numbers like that. It's a factor. So we should have to so wait, with bigger numbers, like I don't know. Hold on.
What do you mean? Okay, so just think of like a department store. You have 9 and 30. What do they have in common?
with you.
No, start with 9 and 30. What number do they have in common?
3.
3, okay. So I'll be 3, and that'll be a 10.
Yeah.
Now, let's look at the U's. So think of you like a Christian McCaffrey jersey. The first store's got 9 of them. The second store's got 5 of them. So obviously they each have 5 in common, right?
Yeah.
You put U5. And look at the V's. You have V9, V2. They have, let's say V is like a Brock Purdy jersey. They have 2 of them in common, right?
Mhm.
Great. So now you took 5 McCaffrey jerseys away from the first store. How many are left?
5.
Right. Well, you took 5 out. There's 9. You took 5 away.
4.
And then Brock Purdy. They had 9 Brock Purdy jerseys. You took 2 out.
Oh, then not what 7.
Good. Can now do the rest. Now do it for the second grouping. So remember, you have U5 that was taken out and V squared that was taken out. So do you have any U's left?
No.
Do you have any V's left?
Yes.
We do?
B squared.
But I thought we took out V squared.
Oh yeah, we did.
So you have Y8 left. That's it.
Yeah.
Okay. There you go.
Okay. Ron, I have to do something real quick. It should be like for like 2
Okay.
minutes.
And again, you can do the same thing, just so you know. Backward grouping.
Okay. Okay. Back. Oh.
Okay. Yeah, so look at the first group. We can pull out the first group.
Um, well, you could first group is why?
No,
Really?
no,
Wait, what?
no.
What would I take out that?
Think of like a department store. We'll say Y is like Michael
Which
Jordan
one?
jerseys. Okay, you have 2Y cubed plus 3Y squared. Okay, 2 and 3 don't have any factors in common. We know that. Now let's look at the Y's. What are you going to pull out? One store's got 3 Y's, the other store's got
Two,
2
two,
Y's.
two, two. Come on.
So how are you going to write on the outside?
Uh,
Y to what
why?
power?
Oh, why to the second?
Okay, good. So now let's look at, so you took away Y squared
Yeah.
from the first, from 2Y cubed. So what does that become?
That's good from 2 cubed. It becomes just one. Or no. That doesn't exist, does it?
Stefan, come on. You got this.
Huh?
Okay, Y cubed. It's got 3 Michael Jordan jerseys. You took 2 of them out. How many are
Oh,
left?
one. One.
Right. So why not say 2Y? I don't understand why you're messing this up.
Okay, I thought you needed a letter, meaning a number.
Yeah,
I don't,
exactly. That's what I want. I want a letter. I want Y.
oh, my
Okay,
bad.
now look at the next one. You have 3Y squared.
Yeah.
Okay, so you Y squared, you cleared out the shelf.
So,
So you
yeah.
just have a 3 left over.
Yeah.
Okay, do the next one.
Yeah, no, I just, yeah. I don't know what I was thinking of last time. I was like,
I don't know either.
I was up against a brick wall or something. I know. Wait. So that looks good, right?
See?
That looks good.
Okay, but you didn't do the second group.
Oh yeah.
When you
So,
pull out the second group.
oh yeah.
I was waiting for you to do that. I didn't hear from you.
Okay, so you 7. You go
Right.
7.
Okay. Okay. And remember, it's supposed to be identical to the other group.
What do you mean?
After you pull out the 7, these are supposed to be identical.
Yeah. Oh. How would it be? Oh, you divide by 7.
Right.
Right.
Exactly. So after you divide by 7, what's left
2.
behind?
2.
Keep going. So you take away 7 from. Okay, just
2,
let's
3,
back
2,
up a little.
3. 2y and 3.
Okay,
Because
take a deep breath. Take a deep breath. 14Y divided by 7. What's that going to be?
2 and then 21.
2Y.
21 divided by 7.
Well, and 20 divided by 3 is
3.
7. Sorry,
3.
20 divided by 7 is 3. Sorry. So there we go.
Yep. So it's just the
So,
same
so,
thing.
so hold on. Wait one sec. So you took out a 7 from that, right?
Yeah.
And you took out a Y squared from the other group.
Yeah.
There you go.
So
Took out
then
Y squared from the first group. Took out 7 from the second group.
is that a plus? That's a plus, right?
That's Y squared plus 7 times 2Y plus 3.
Oh no, got that one wrong. So my last try and I had a typo. Oh no. Dude, it's the second time that happened to me today.
Okay. So now do the next one.
Yeah, right here. So what's common is 7. No, 4.
Yeah, you gotta look at the first group. Okay, so you take out 4,
Yeah.
and there's more.
Yeah. 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 So that would be 3. Um, wait. So I got the first one. So then for 28, it would be 7. Right?
Hold on. So what did you pull out of the first group?
4.
And
Oh, I could have went. What's 4 and
now do the letters. You took them. You took care of the
4 and 7.
numbers.
4 and 7. 4 and 7, or is that right?
Hold on. Okay, let's just back up here. Okay, so 12u squared is this, right? 28u squared is this.
Yeah.
Okay, and 12 really is 4 times 3, right?
Yeah.
So let me clear this out. So it's really 4 times 3
Yeah.
times u times u times u. 28 is 4 times 7 times u times u.
Yeah. Okay, so yeah, so then, well, there will be no U's left because they just cancel out? Because they both have 3 U's, and I thought with this factoring, it would cancel out.
Okay, take a deep breath. Okay, 12u cubed, 4, 3 u u u. 28u squared, 4, 7 u u. What do they have in common? They have a 4 in common.
Yeah.
They have a u in common.
Mhm.
They have another u in common.
Yeah.
Take them out.
Mhm.
When you take them out, you have 4u squared.
Yeah.
And what's left behind? 3u
For you and 7.
and 7. That's it. That's
Yep.
all this ever is. I have no clue what you're doing.
I
You're
just
getting random
overcomplicated.
numbers,
I
random letters.
overcomplicated. I overcomplicated.
No, I don't know what you're doing. I don't.
That's what my teacher was saying. He said I overcomplicate stuff.
He's just saying that because he wants to say it. You're not thinking that you're just not thinking through the problem. That's what you're doing. I'm being honest with you. You're not thinking it through. So think it through. You're better than this. Let's do the next one.
Yeah.
9u plus 21. 9u is 3 times
Oh, I
3u.
thought I did.
Well, you're not done yet. Wait.
I know.
Clear,
I
clear it.
accidentally did. It's like it's like my it's like
Just
like
clear it. Just clear it. It's
yeah.
okay. Don't worry about it. You get another attempt anyway.
I get too much, but it's just my like mental. Like I always just go
Okay.
to submit
But
it.
we're not done yet. Okay. Let's keep going. Clear it, please.
Oh
Okay. Now let's look at 9u and 21. You
yeah,
have 3 times 3u and you have 3 times 7. What did they have in common? A 3, right?
yeah, 3.
So put plus 3.
Mm-hmm.
And what's left behind? 3u plus 7.
So yeah.
Exactly. So it's 4u squared plus 3
Mhm.
and 3u plus 7.
Yeah, I mean, yeah, but this I get that. Oh yeah,
Yeah,
so
because 4u squared is multiplied by 3u plus 7, and 3 is also multiplied by 3u plus 7.
yeah.
So 3u plus 7 gets factored out. It's kind of like saying 4u squared times a plus
Mm-hmm.
3 times a. Pull that a out, you have 4u squared plus 3,
Yeah.
right? So
Oh, and yeah.
Okay, same thing. Okay, 5x is 5 and x, and 3x and y. What do they have in common?
5x and x.
That's it. So it's 5 plus 3y.
Okay, that's very easy.
And the other one just has a negative, so we pull out -1. 5 plus 3y.
Yeah.
X minus 1, 5 plus 3y. There you go.
Wait, yeah, so then yeah, the first one. So if it's just the x, if it's just a variable, it's just that simple, right? You just take the variable and then just
Correct.
yeah.
Correct.
We're not done though, are we?
Yeah, keep going. No, the final answer is right here. Right? Because that's the whole point. To
Yeah.
have it factored.
I try the Shamrock Shake from McDonald's. It's like not making me think straight.
Okay, sugar's not good sometimes. All right.
No, it's like, no, I took one sip. It's like the greenest thing ever. It's the St. Patrick's Day, and like I'm off the walls. I don't know why. It's kind of concerning whatever they put in there.
Okay.
I don't feel okay.
Okay.
Oh,
So this one next. We did this, we talked about this already. We
yeah.
have 5W6. So think of it this way. 5W, right? Then X, 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 X,
Mhm.
Y, 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 Y.
Yeah.
And this one here is 25, which is going to be, hold on, 25, 5 times 5, W, 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 X, 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 X. Okay, now, so start with the fives. They have a 5 in common, right?
Yeah.
So you take it out and cross these off. Okay, W's. How many W's do you have in common?
1, 2, 3, 4, 5, 6.
No, on each side.
Oh, 3.
Right, so take those out. So you put W cubed.
Yeah.
X's, how many X's do they have in common?
Oh, 5.
Right, so take them out.
Yeah.
Okay, now you just tell me what's left behind. You have W, 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 X, and Y, Y, Y. So what's that going to be? W to the
4th. Oh,
third.
3rd. Then Y to the 4th.
Let's start with the first group.
Oh, yeah.
W to the third.
Yeah.
And then how many X's left?
Um,
1X.
1x.
And then Y to the
And Y to the 4th.
good. And then the second grouping, we cross off most things. What's left?
Um,
I circle it for you.
a 5. Five.
five.
Five. Hold on. I
I
can't.
circle for you.
No, the zoom camera, like the
Well,
zoom,
it doesn't
like
matter. You took 5x away anyway.
yeah.
Yep.
So
You had x6. You took five
five.
x's out.
Yeah, so it's just 5x.
5x, good. Okay. Well, it doesn't matter whether the Zoom is frozen or not. You should know because you have that. You see the question. I told you took out that many x's.
My bad. Yeah.
So do it like this if that helps. Once you get good with it, you can to be more quick and just use properties of exponents. But for now, the properties of exponents are not working for you. So you really got to list them out and just cross them off.
Yeah, for sure. Oh yeah, no, that helps me like visualize it.
If that's what's going to take. I mean, that's fine. That's what we'll do.
5-3 W3. Um, what was the second? I know the last one. What was the second one? It was Y4. It was Y4 plus 5, Y4.
Minus 5x.
That's 5x, yeah. That
All right, factor by grouping. Here you go.
okay. Um, so X is common.
Yep. Okay. So figure out what to pull out.
Be X. Okay.
Okay. Yeah, let me know when you got it.
Hold on. So it'll be X, right? So write this down again. Wait, so
Okay, so what's your answer?
I don't know. I'm having a problem with the first half of it. The second half is really easy to me.
Okay, x cubed. How many x is that?
3.
6x squared. Well, they have a -6 and you have two x's, right?
Yeah.
Okay, what do they have in common?
They both have 2 X's.
So take it out. When you take it out, that goes away, that goes away. What's left behind?
-6.
X -6. Good. Okay, 7 -42. What do they have in common?
7.
Right, take it out. You have x -6 again.
Yep, X -6.
So you have x squared plus 7,
Yeah.
right? Okay, I can't keep doing this for you. You got to do it. I know I
X
can do it.
no, X
I've
plus
been incredibly consistent with how I do it. There's no run.
the same. That's the same exact one. I knew that because
Yeah, just do it.
You do negative 42 divided
Okay.
by 7, that'll be 6, and then the other one divided by 7 will be 1. Wait, why is it not letting me write negative 6
So it's x squared plus 7
plus 7? Yeah.
and x minus 6.
Yeah, I'm not like that Shamrock Shake is just taking me over right now. Coloring it is not doing well for my brain. So you just group these together.
Yeah, this is the last one.
They have V in
Yeah.
common.
Yeah.
V, right? They have V, so no. Okay. You write them down. Wouldn't it just be then this?
Okay, and then V.
E minus 2.
Good, much better.
Sorry, I was a little unfocused tonight. I'm not like, this Shamrock Shake was
No,
bad.
it's just don't confuse it. So okay, and then I think I see you again because I have another call coming up. She just showed up. Well, glad we got done. Let's see here. 1 sec. I think we see each other on um yeah 7 o'clock on March 18th, a Monday. Okay, cool. I'll see you then.
Then have a good night. Bye.
Bye.
Hi.
Hey, Bren. So you're in Modesto now?
Yeah, I am.
And how are you feeling?
I'm okay, but can we make it half an hour? Because I'm
Sure.
gonna go
You
to
need some
bed.
rest. Yeah, totally. I get that. What are you guys working on?
Well, I had my test this morning,
Oh, you had a test. Oh, that's right. I think I
and
emailed you some of the 30, 60, 90. Yeah, yesterday I did.
yeah, there were a couple things that I didn't know though.
Like what?
Like, I don't know how to conjugate polar form. It's asking me to conjugate the polar form, and I don't really know how to do that.
What do you mean by conjugate the polar form?
I don't know. That's what it's asking for.
I
It's
mean,
like,
what were you given? I guess that's a better question to ask.
I don't know, like 7 cis 15 pi over 12, and then it asks for that to graph that and then graph the conjugate of it.
Well, the conjugate just means you switch the imaginary part from positive to negative. That's all. That's all you do. I mean, if so, it
Yeah,
asks you to
but
graph
if
something,
it's
and then
in polar form, then what do I do?
well, if it's polar form, you should have the imaginary number, and then switch the sign of it from positive to negative. I mean, switch the sign of the imaginary part, because you still know what the imaginary part is, even if it's polar form. Just means you have a trig function, but you still have an I next to it. Like
So,
you might have like two cosine theta plus three I sine theta. Well, then fine, just change the whatever's in front of the I, change from negative to positive. That's it.
oh, so then it would be like cis negative 15 pi over 12.
Um, well, I don't know. I mean, hold on. Can you see my screen?
Uh-huh.
So say I have like 4 cis 15 degrees. We know that means 4 cosine 15 degrees plus 4 I sine 15 degrees. We know what that means, right? So
Mm-hmm.
if you want the conjugate, then it would just be 4 cos 15 degrees minus 4 I sine 15 degrees. That's all.
And
That'd
so
be your
then how would
conjugate.
I graph it differently?
You,
How does
you,
it
gra-
graph differently?
you graph the first complex number, which I don't know what 15 degrees is. I just made that up, but wherever that is, you have a dot here, and the other
Mm-hmm.
one would be um like over here somewhere.
Oh, interesting.
That's all.
I don't know if I'm doing the algebra wrong, but the other thing that I kept running into was
Mhm.
it like it turned out right, but it felt wrong when they're giving me like two of when it's like a conjugate divided by the original one. Um,
What do you mean by that?
like z over z conjugate, and it's like something like that. And then Wait, no. No, no, no. It was that it was a rectangular complex number and the values for X and Y were the same, except the Y had an I after it. And so then the value I got for R in the polar form was 0.
I have to see the I mean, well, hold on. Let me start a new sheet here.
I don't really know. I just kept getting 0 for a lot of things, and I'm like, I don't know if that's exactly right.
Wait, so
But
what was the question again?
um I'm pretty sure it was like 4 root 2 minus 4 root 2i.
Okay.
And then it was like turn that into polar form. And so then
Yeah,
I,
so you just have to find the radius and then find the angle, right? We've talked about that. So the radius would
yeah,
be you got to square each of them, so that'd be 32 plus 64. So radius is 8, and the angle would be in the second quadrant. The angle would be 135 degrees or 3 pi over 4. So it'd be this.
yeah. And then I think I was
That's
fine
it.
on,
Yeah, that's all. So why are you getting 0? I'm confused.
I don't know. I think I remembered it wrong, but there was something that I kept getting 0 for, and I was like, that's kind of weird. I don't think it was that one though.
Okay.
But
But
I
remember, you have to
was,
square both of these and make sure the negative's not inside the square. That could be it. I don't know.
yeah. Well, I was fine on going from rectangular to polar, but I was having trouble going from polar to rectangular because we weren't allowed to use our calculator to do trig functions.
Go for polar rectangular. You just do r cos theta, r sine theta. That's it. R cos theta is x and r sine theta is y.
Oh, I totally forgot about that.
Yeah, of course. So we talked about it.
Oh yeah, I definitely forgot about that. Because we had our
Because x over r, remember from the unit circle, x over r is cosine. Y over r is sine.
yeah, we had our like our reference sheet.
Hmm.
Yeah, I forgot about that
Okay.
one. I should have. I'll
Yeah.
remember that.
Yeah, totally. Yeah.
And then there was like a few things on exponential, but that one's like easy if you have the polar form. And then there was one where it's like they give you
Uh-huh.
three complex numbers and you have to make an equation out of two of them to find one of them or something. That one was I think I did fine on. I don't really
Okay.
know.
Yeah.
Um oh, and then there was the one where you had to find the roots. Um where yeah, where I just use the
Yeah, we talked
uh
about that. Yeah. Yeah.
Demov's theorem. So
Sure.
I think it was like okay, yeah. I think it was okay.
Okay, good.
I think it was just the I didn't know how to conjugate a polar form. I might have a thing that's due
Okay,
next.
so we got.
Let me check. I don't actually know if she put it on Canvas because I think she was trying to get us copies of it, but like the printer wasn't working or something. Um, yeah, I found it. Yeah, because it's a new unit. I guess. Okay, I just put it in the drive.
Yeah, let me check. Right. See here. Um, let's see now. Okay. So just out of curiosity, do you drive yourself out to Modesto, or your dad drive you, your mom drive picks you up, or
It's usually whoever is getting me drives me because I can't
okay?
drive yet. I'm
Yeah,
sure
because
they'd love if I
that's
could.
a long, yeah, that's a long distance. I
Yeah.
was just curious. Okay. All right. Fair
I
enough.
don't think they would let me drive it by myself either.
How
So
long is the drive in each direction?
it's 100 miles.
Yeah, it's kind of like driving from here to Sacramento, I guess. Yeah,
Yeah, and it's like
roughly.
it's mostly scenic. It's like through the Altamont Pass though.
It is. It's true. Yeah, that's true. Um, cool. I was curious. So here, yeah, you just making a table, right? Just graphing polar curves. Okay, yeah. So yeah, like you do like zero. We'll do this in radians. Zero, 5 or 6, 5 or 4.
Wait, so can we
Hmm?
go back? If R equals 2 cosine theta,
Hmm?
um,
I'm just making a table and just graphing it. That's all.
okay, so then we're just deciding arbitrary values of theta and then seeing
100%.
what R will be.
100% correct. Yes.
And so then it would end up being like R cosine theta cis something else,
No,
but
no,
this
no, no, no,
theta or
no. You're just graphing. You'll see. Let's just do this first. So we'll do 0.
okay.
I'll do pi over 4 actually. Pi over 2. Then 3 pi over 4. Pi. Pi over 4 is root 2 over 2, so that's root 2. Negative root 2. Okay.
Okay.
Then what you do, so it's called polar curve. Let me move this over. Okay, here's what you want to do next. So then what you do is so each inner circle is a radius. 1 sec. Ah, okay. So like 0, 2. So basically, when the angle is 0, you want to be a radius of 2. So it's like right here.
Uh-huh.
Then when angle is pi over 4, you want a radius of root 2, which is probably over here. Because root 2 is between 1 and 2.
Mm-hmm.
So basically, you got to put on the circle where that radius, but you don't like, so this is radius 1, this is radius 2, this is radius 3, radius 4, and so forth.
So why are we doing this though?
We're gonna make a curve. We're just plotting these points
But why are we making a curve?
because you're asked to, you're told to, they want you to.
Well, yeah, but like, what does this mean? Like,
It's just a graph. That's all. You're just graphing. You're
okay.
graphing a curve. I mean, you're using polar instead of using x y, you're using r theta. That's
So it's just getting us used to graphing in polar
yeah,
form?
exactly. That's all it is. Yeah,
Okay.
that's all you're doing. Pi over 2, but the radius is 0, so it actually would call us the pole.
Oh,
3 pi
okay.
over 4 and negative root 2. Now, when it's a negative angle, it actually jumps over to the other side. So it's right here. Then pi negative 2 jumps over to the other side, so it's right here. 5 pi over 4 but negative root 2, so it jumps over here.
So if it's a negative r, then you act as
It rotates 180 exactly.
okay.
And then the other one's 3 pi over 2, but it erases 0, so it doesn't move. It just stays at the pole. 7 pi over 4 root 2. Yeah, so you want to just gain this. So it's just a circle, which makes sense because if I square both sides, actually, hold on. Does that make sense what I'm doing? Yeah. Actually, let me back up a little bit here. Yeah, it does make sense because then what happens with this actually, let me back up a bit more. So we know r is root x squared plus y squared. And cosine theta is x over r. Actually, let me back a bit more, sorry. So you know cosine theta is x over r.
Mm-hmm.
So then r squared, and r squared is that. And that ends up becoming a circle like this. You know, you can complete the square. Yeah, so that's what happens. It's kind of like 1 comma 0 is your center and the radius is 1, which actually would look like this. So yeah, I mean, if you were to convert it to rectangular coordinates and graph on a rectangular coordinate plane or XY coordinate plane, yeah, that's what you get. So yeah, that's all.
Mm-hmm.
So yeah. This curve is called this curve is called a circle radius 1 center. So we've got the equation r equals, yeah. So yeah, and r equals a sine n theta, or you could do this in Desmos, different values, kind of see what happens. Yeah, convert to rectangular form. That's not hard. We know that. Like for example, r equals a times y over r, because it's a sine theta, so r squared, or x squared plus y squared. I mean, I think it's as far as I can go with that. And you can, and we are, you kind of do the same thing. It'll be x squared minus ax plus y squared equals 0. If you convert that, because remember that's x over r, and you smooth things over. So, yeah, if you go to Desmos, polar curves, Desmos. Why am I seeing this line? Leave. Hold on, it's being stupid. Yeah, if I were to do like r equals 2 sine, look at theta. Here we go. Yeah, so you get a circle like that. But then if I change that to say like 4, see it gets bigger, or don't have that. Where I put a negative goes below. Then you get some weird stuff like this, which they're kind of neat shapes, actually. Or if I put like a number in front, you get these rose petals. I think I'd change the position of it, but yeah, if you do cosine, we can always flip it. So anyway, that's what's going on there.
Yeah, okay.
Hold on, let me go back to the documents. Share screen. There we go. Yeah, so we saw that that creates I think called Limicon, I think what that's called, but yeah, you could do a table again. 0. So if you put in 0, that's 2, that's 4. Pi over 4, 2 plus root 2. Pi over 2 is 2. 3 pi 4, 2 minus root 2. 0. Root 2 over 2 was negative. And it's back to maybe 2. And if I plug in 2 pi, go back to 4. Yeah, 0, 4. Then pi over 4. 2 plus root 2 is like 3.4 something. Like that. Then 3 pi over 2, 2. 7 pi, I mean, obviously the calculator or Desmos is better, but 2 plus root 2 is that. So the way the curve goes, it kind of does this. And then it kind of comes in and does this, does that. So there's a bit of a dimple there, if you want to think like that.
Hmm.
And if I go 2 plus 2 cos theta, see, you get that.
Oh.
Yeah.
I expected it to be a little more heart-shaped, but
Yeah, exactly, right. But what you could, Well, that's more of a loop.
I guess it's abstract.
Yeah, 4. Yeah, but it's called a cardioid because it does kind of look like a heart, right?
I can kind of see it, yeah.
Yep, yep. So that's that. They're kind of cool. They're really cool, actually. Really cool shapes. Yeah, cardioid. There you go. Because like like a heart.
Yeah.
And kind of ask you how's the value of A affect the graph. Well, I think it just gets bigger. Like if I were to change like, let's say 4, 4, yeah, it just gets bigger. That's all. You're kind of and notice how this right here is actually 8, right? Because 4 and 4 is 8.
Oh, okay.
So that's something to kind of keep in mind as well. If I did cosine, I think it just or switch to the sine, I think it rotates 90 degrees. Yeah, just rotates 90 degrees. Put a minus out in front, then it just flips over. So yeah. Yeah.
Oh,
And then
okay.
yeah, convert polar equation to rectangular form. So yeah, just you could replace sine theta with y over r. So you would have something like this here. Yeah, multiple says by r. R squared is x squared plus y squared. That's root x squared plus y squared. Yeah, anyway. Not sure how much we have to simplify that one. Yeah, these are going to be rose petals. We change that to,
Rose petals?
yeah, it looks like this. Oh, sorry, never mind. Oh, no, wait, it was a sine 2 theta? Yeah, my bad. That's what I meant to do. Yeah, like that.
Okay.
Now, and if it's cosine, it'd just be rotated. But if it's even, then you double the rose petals. If it's odd, then the rose petal is what you see, and just they all get spaced out equally.
Oh, interesting.
Yeah. So
Cool.
yeah, so there's still a lot going on here, which we could probably talk about on Sunday, 1 o'clock. So we'll end it early tonight because yeah, you need some rest. So
Yeah. Okay.
well, good. Well, at least we started this topic, and we'll do more of it next time.
Okay. Thanks.
All right. Goodbye.
Bye.
Oh.